Here we go. There we go. Morning, everybody, and welcome to episode 50. Finally, we made it to 50. That's exciting. Of MakerBot Chats. My name is Felipe. As always, it's a pleasure of having you guys here. We skipped last week's because we were talking about this, this week's topics a little bit on a webinar, so we didn't want to double down on the content. However, I do have a few additional items to discuss. Specifically, we'll be talking about the new materials that we introduced last week from Lehvoss. Two new composites and one nylon. Really exciting materials. In particular, one of them, and I'll take you guys through all of those. We'll do a quick rundown of what those materials are. We'll do a quick test, stress test. That's why I have like the two cameras. This guy here looking at my, let me switch views real quick. But looking at the detail of my setup here, we'll be doing a stress test with the samples. I've got specifically the PET carbon fiber from Lehvoss. The name is a little bit longer, so apologies for that. But in any case, it's a PET with carbon fiber embedded in it versus an ABS sample. So this is our standard ABSR, material. We'll be testing both of them. The reason being, we were really surprised about the results that we got last time on the PET. So I want to just to talk about a little bit more on that material. I think that we need to double down on what it is and what could it be used for, because so far, and I'm hoping that the results will sort of reiterate that, this is the strongest material outside of metal that I tested so far, that's printed on the method. So really impressive material at that. So let me take you guys real quick through these materials, the overview, right? I don't want to take too long because I want to get right into the testing part of things. So to start, as you know, all of these are available through our website. You can go into the materials tab, and under the materials tab here in polymers, you have the PAHT 9825. That's a nylon. Here you have the PET carbon fiber 9780. This is the one that I've been talking about, and just nylon carbon fiber, which is called CF 9891. The specific names for each of them, sorry. So here we go. This is a nylon, right? So LUVOCOM 3F PAHT registered 9825 NT. A little bit of a lengthy name. This specific one is nylon material, which it's really good for higher temperature applications, right? And also really great for applications that require a little bit of exposure towards more humidity, right? So it's not going to be as sensitive to humidity as other materials. You can use it both with the Method and the Method X. You will need to use it with the Labs extruder that I got right here. We'll talk about that in a second. I think that most of you guys know, but the Labs extruder is essentially our way of opening up the method to any third-party materials that you would want. Now, in particular, these materials from Lehvoss differ a little bit in that sort of blanket statement of any third-party materials, in that we actually test some of the materials out and create profiles for you guys to use, so that saving you a few steps in the process of calibrating the machine in terms of the print temperature, the chamber temperature, the setup that you should be using. But in any case, Labs, the open platform from Method, enables you to print with any material that your heart desires. But in this case, we actually have these three material profiles already dialed up for you guys. So first material, nylon. Well, I'll call it nylon, but it's the PAHT stands for the high temperature materials from LUVOCOM. So definitely able to withstand, as I said before, a little bit of higher temperatures in specific applications. Now, if you guys need the actual rundown of the the technical specifications of the materials, do reach out to them. I'll be posting them here in the pages along with the print profiles. But in any case, if you have any questions, don't hesitate to ask. If you're watching us live, Alejandra is collecting all of your guys' questions on the right-hand side of the screen. If you're watching our recorded version, you can definitely comment on the section down below, and we'll address those questions in the future. Second material, PET carbon fiber 9780 LUVOCOM. Oh, sorry, there's a typo here. LUVOCOM 3F, right? So this particular material, it's the one that I've been talking about since we started. It's a PET composite, right? It's not a PETG, which is, I think, one of the important things that we learned about last week. The PETG adds glycol to the material, makes it a little bit more straightforward to use, but might change the structural, the strength of the material, right? So really strong material. We'll get into that in a second. Also really good temperature resistance, as you can see here. It's about 120 degrees Celsius. I think it can go up to 150 at at a point, meaning constant 120, it'll be okay. You can hit 150 every now and then, and the material, the part, will still resist the heat impact. Impressive combination. Also, you're able to print it with both the Method X, the Method, and also, if you were to have the Method carbon fiber edition, you can print it with it too. As I said before, you will also need the labs extruder. And as a support material at the moment, we're recommending PVA. We're testing out SR30 as an additional option for support material, but we're not done with that bedding process just yet. So for now, I've been using it with either PVA or breakaway supports. Really good and straightforward experience from my perspective. And then final material, 3F PAHT CF 9891 from LUVOCOM. So this is also a composite. This one is going to be a nylon carbon fiber composite. Also pretty strong. Similar, if you want, if you've already experienced with some of our composites, it has similar properties than that of the nylon 6 and nylon 12 carbon fiber from MakerBot, right? Really strong, super stiff, and it'll also do 150 degrees, when talking about the heat resistance or the temperature itself. You can use it with Method X, the labs extruder, the support material at the moment. The recommended one is PVA. For all three materials, and we'll talk about the print specifics, right? But for all three materials, we do recommend that you run the chamber temperature at around 60 degrees, maybe 70, depending on the support material that you're using. That's why we've kept it simple with PVA for now. But we, after talking with Lehvoss, we did find out that the heated chamber makes a ton of a difference in regards of how these materials print. And that's not, coming from us. That's actually them testing the materials out in open printers, in heated build plate printers, and full enclosed heated chamber printers, and the difference that they actually see on the material performance, right? So real quick, we now have 30 materials, super exciting, from Method, 4 standard polymers, 6 that I would call kind of high temperature polymers, 2 composites, 15 lab certified. So those are the materials that, as I said before, come from third parties, but you can use, and we've already run the profiling for you, and 3 soluble support materials, PVA, SR30, and rapid rinse. I won't spend too much time here. We've talked about the 3, new materials from Lehvoss. However, I do want to spend some time in talking about the test that we'll be running out today, right? We've done this before. I'm sure that you guys have seen it in the past. If not, it's a very straightforward test. I've been printing out these S hooks in my Method in different materials, same geometry, same infill, same settings or similar settings. It's just a matter of printing correctly. But 20% infill, same sizes, and essentially we'll put the hooks here on the vise and measure out how much how much force it takes to break them apart. Today we have specifically the ABS sample and the PET carbon fiber sample from Lehvoss. So real quick, when talking about the print profiles, and again, we're collecting questions as we go, so I'll address those at the end of the chats. The print temperature for the carbon fiber, this would be the nylon carbon fiber. So PAHT CF 9891 from LUVOCOM. That's 290 degrees in the nozzle, 60 degrees in the chamber temperature, and the support material will be PVA. We ran this test last week with it, and the average amount of newtons that it takes for us to break down the sample is around 260. So as you can see there, first sample was 269, second one was 253, so just around 260 overall. Second sample, this is going to be the nylon material from LUVOCOM as well. So LUVOCOM 3F PHT 9825 NT. This is going to be printing at 270 degrees on the nozzle, 60 degrees on the chamber temperature, and finally using the support PBA as a support material. You can also use breakaway, which is essentially the same material as a support for itself. One thing to note here though is that you really want to be able to check in the actual printing temperature of the nozzle. If you go into your printer settings under information, under advanced and sensor info, you'll be able to see both what's the temperature that you sliced for. So let's say that you sliced for 270 degrees, and what's the actual temperature that the extruder is reading, right? So sometimes you might need to compensate. Let's say you sliced for 280 degrees and the extruder is hitting 265. You might want to compensate that on the slicing settings just to be sure. But just have a look at that. It's also really interesting to see all of the available information that you get from the method at a glance. Anything from the chamber temperature, the extruder temperature, different points throughout the printer that read out temperature settings, the humidity sensors in the drawers, and so on. I won't spend too much time here because I really do want to get to this guy and the testing process. So this was a test that we ran last week. 262 newtons, 268 for the second sample, 364 for the average. The print temperature was 285. I actually had to slice for 290 degrees Celsius just to be able to heat that 285 consistently. The chamber temperature, that's pretty straightforward, 60 degrees Celsius. Support material PVA, I was actually using no supports for this particular sample. But with that, let's fade here to the actual test, right? As I said before, I'm going to be testing out first the ABS. So this is an ABS, gray ABS sample, printed out on the method, 20% infill. Oh, goggles, I always forget, but better to be safe. You'll see why in a second. But in any case, sample number 1 from ABS, we are looking for a number of around 250, but we'll see how it does. So 20, 50, 80, 100, 140, 160, 180, 200. And the peak, I'm sure, let me just make sure that you guys are not getting too much glare out of this. So the peak was 202 newtons. Let's run a second sample. That's kind of one of the reasons why we run multiple samples here is because we want to make sure that we're taking into consideration, any weird deviations that might be just due to the one sample. So we want to take averages here. So 200, let me write it down. Sample number 1 in ABS, that's a peak force or peak load of 202.5 newtons. Let's do sample number 2. Resetting my jig here, running it down there to 0, and making sure that you guys are getting a good readout. Yeah, and here we go. So sample number 2, also ABS. Let's see what happens. 50, 80, 100, 150, 180. There we go. Peak of 190.5 newtons. That's sample number 2 from ABS. You can see my writing here. And now, ABS is a little bit of a standard material. It's in a way a benchmark material for us to measure things up against. Last time on last week's webinar, and we'll be posting the link to the webinar. It's definitely a more deep dive into the material properties. We actually had one of Lehvoss's, Tiago, one of Lehvoss's materials engineers, come in and chat with us about the material properties. So really interesting if you actually want to get really down into the specifics of the materials. But last week we only had time to test the materials, the new materials themselves. We didn't really perform a benchmark. We had to rely on the previous results that we had already available for us. But in doing so, we realized that we might be into something really interesting here when it comes down to the PET carbon fiber material or composite. So let's do that sample now. So PET carbon fiber sample 1. and resetting here. There we go. So PT sample 1, zeros, you guys can see that, and starting the pool. 50, 100, 200, 300, here we go, 330. So that's 328 actually newtons on the peak load. That's sample number 1. Sample number 2, let's reset real quick here. And again, you know, just as a reminder, we just got on the 200 out of the ABS. It's really interesting to see how immediately, like, the loads that it'll take jump right away. Like, it just spikes up all the way to 200, the PT. So sample number 2, PT carbon fiber from Lehvoss. Reset, and here we go. 50, 100, 200, 300, 326 peak load. So 326 newtons. And if I go back here to my very handy dash, this is slightly here, slightly lower than the results that I was getting last time. However, and let me just make this full screen for you guys, right? So last week I was getting readings of above 260 newtons. That's impressive. This might be due to the fact that you know, I've been using the material quite a bit. Maybe it's gained a little bit of moisture from the environment, I don't know. But still, these two samples were above 300 newtons, right? We hadn't had any material breach that amount before, outside of metals, which by the way, I cannot print this in metal, and you know, there's no way I'll be able to break it. This probably goes off the chart also for the force gauge as well. So really impressive to see, again, over 300 newtons, 330 actually, well, 327 in average for these new samples. The highlighted materials, so the yellow materials are the new ones. The carbon fiber composite with PET, the nylon composite with carbon fiber, 260. As I've said before, it has a very similar performance than that of the method carbon fiber. You know, some of you guys might be wondering what the difference is. There are some differences specifically in regards to the maximum heat temperature, but it all depends on the application, right? And finally, the nylon material from Lehvoss, which is around 220 newtons, right? So pretty in line with standard nylon and also the nylon 6 carbon fiber. So again, impressive material. I've been printing with it a lot. Let me switch back here to my main view. Here we go, the webcam. And I'll start taking some questions from you guys as we go. So thank you, Alejandra, for gathering those up for me. But, you know, all in all, this is actually, you know, a little cover printed out on the PET. Let me use the second camera, so I think we'll get a better view of it. Really nice material to print with, right? Look at the surface finish. It has kind of like this glowy, shiny aspect to it. Super strong, right? These walls are about they are 3 millimeters, you know, wide, and they are really, really stiff. I know that this is a very, you know, kind of a very basic way of testing it. You guys have seen the actual force measurement happening here, but it's definitely a really stiff material, really stable, really straightforward to print with. The only thing that, as I said, you guys want to really that you guys want to keep an eye out for is the extruder temperature. So you want to make sure that that extruder is actually hitting the 285 degrees Celsius. And outside of that, you know, pretty straightforward experience, I'll say that. I'm super happy with these materials. I also got this other sample. This one I printed out with the nylon carbon fiber material. The actual name, because I keep forgetting, you know, the complete name for it. So this would be the LUVOCOM 3F PACF 9891 black. So, well, yeah, that material. it's a composite made out of nylon and carbon fiber, really stiff as well. But I would say that the PET just blows this out of the water, right? 100 newtons more than our nylon carbon fiber. That's pretty impressive. And these materials are already pretty stiff, pretty strong, super lightweight. I think that we do need to do a few more tests here just to get better insights on the possibilities for this material, because I'm definitely impressed. So with that, I'll start jumping into the questions that we have here in the back end. So what are some application examples for these materials? Okay, I'll start by saying that both, well, the nylon material, the carbon fiber, nylon carbon fiber, and the PET carbon fiber, they do pretty well, in regards to the strength. However, the nylon carbon fiber will be a little bit more sensitive to humidity changes, right? So it will want to absorb moisture. You'll want to keep an eye out for that. That's also part of the reason why the materials come not only in the box, but also in these aluminum bags and resealable bags. I'm sorry about the noise, but the filament comes inside of these bags. The bags are resealable. They come with this nice Ziploc of sorts on top. So you really do want to make sure that the materials are kept dry and closed when you're not printing with them. All in all, I would say that the applications range from things that require being exposed to temperatures above 100 degrees Celsius but below 150. Things for the PET, definitely things that could be a little bit more exposed to the elements, because it's going to have a better tolerance towards or against humidity. And the standard nylon, well, it's a nylon, but it's a high temperature nylon. So again, better suited for applications that require exposure to higher temperatures. What are the printing guidelines or settings used? Okay, so as I said before, overall, all of them were using PVA as a support material. All of them were using 60 degrees in the chamber. You can print them all with any one of the method printers, and the difference will be in the nozzle temperature. The highest temperature being for the PET carbon fiber, which will go to 285. The lowest to the nylon, PAHT. I forget the name. Apologies. It's a lengthy name. The lowest temperature will be for the 3F PAHT 9825. That's the nylon, the nylon. And in between, with 200 and 280 degrees for the extruder itself, we'll have the 3F PAHT CF 9891, which is the nylon carbon fiber composite. Next question, what support material is necessary for each of these materials? So as I said before, right now we've been using and testing out the PVA. Also breakaway, really good material to use breakaway with. If you're having a straightforward geometry like this one, some of them you can actually go by without having any support at all, depending on your geometries, right? But yeah, PVA for now. We're testing out SR30. SR30 does need the usage of method X, because you have to have a higher temperature in the chamber. It's somewhere between 70 and 80 degrees. We're fine-tuning that, and we'll have an answer shortly on that regards. But overall, straight answer right now, PVA or breakaway supports for any one of these three materials. What extruders are these materials compatible with? Right, great question. So I said it before, for the material itself, you'll need the LAPS extruder. For the support material, you'll need, if you're using, I don't have the extruder number 2 here. Oh, actually I do. So if you're using the PVA material, you'll need the support 2 extruder. That's our dedicated PVA extruder. If you're using SR30, you'll need the 2XA extruder. This extruder can handle both SR30 and rapid rinse. Rapid rinse works with ABS, separate conversation, but yeah. The combos, all in all, it's LAPS plus one of these two support extruders. As you guys know, Method runs 2 extruders at a time. One is dedicated for the material. The second one is dedicated for the support material. What are the properties of the LUVOCOM PET carbon fiber 9780, and what makes it unique to work with? Right now, the first impression that I get is that it's really easy to print with, really stable. Also, we were talking about last time with Tiago, the materials engineer from Lehvoss, about the fact that this material is actually isotropic. So you may have heard about anisotropic materials that will behave differently depending on the way that you apply the force to them. this material is really consistent in the way that it resists force, regardless of the axis, right? If it's coming from above, from the sides that it's coming from, right? So it's very even in the strength that it has. So really impressive strength. I need to do to find out better ways to exemplify that. Right now we only have that benchmark test, but so far really nice material to work with. What indication shows that the filament has too much moisture content? Well, if your parts start to become a little bit brittle, more than useful, if your filament actually hisses out, there's a, people talk about this popping sound, which I've heard before, right? There's like a popping sound in the material when it has too much humidity. That's literally because you're making the little droplets of water in the material, boil up as they run through the extruder. So if you hear any hissing sounds, if your parts become a little bit too brittle, if the filament itself, right, becomes kind of, it becomes kind of gooey in a way, depending on the material that you're using. But yeah, between the hissing sound and the parts, also you can get some extruder jams depending on the material that you've used. It might be a good indication that your material has too much moisture content. However, don't despair, because the method itself has a feature that will allow you to run the heated chamber at 40 degrees Celsius, I think. That's more than enough to get rid of most of the moisture content in the material. So I would highly recommend that you do that. And again, keep an eye for the way that you store your materials, right? When you're not using them, the materials they need to be in the dry bag, well kept, safe, dry, without being exposed to the humidity. Some of you guys might like hanging the filament in the wall. It looks awesome. Believe me, I would do that if I could, holding this wall, but that degrades the material, right? So you want to keep the materials dry, safe, enclosed, and as pristine as possible before you're printing. So with that, I think that we've covered all of the questions that we had today. Thank you guys so much for joining. If you have any questions, do reach out. Hello at MakerBot, Felipe at MakerBot, our social handles at MakerBot, both in Instagram and Twitter. And yeah, thanks Alejandra for gathering the questions in the back end. And for now, let us know if you have any additional ideas on topics that you want us to touch on, applications, materials, whatever. We'll be happy to address those out. But for now, thank you guys so much for watching, and we'll see you next time. Bye.